Now let's look at the cooling curve. The cooling curve is something quite similar. Okay, this is when the liquid naphthalene is being cooled to solid. So P to Q. Okay, P would be the original temperature of the liquid naphthalene, and then to Q. Q is the freezing point. Actually, freezing point is the same with the melting point. Okay, freezing point is the same with the melting point. Just that melting is solid to liquid, freezing is liquid to solid. But when we talk about the point, point means the temperature. The temperatures are the same. You can see freezing point of the naphthalene 80 degrees Celsius, and then the melting point of the naphthalene also 80 degrees Celsius. So they're actually the same. Now P to Q, what happened? Liquid cools until it drops to Q. At Q, liquid starts to freeze or solidify and change into solid. So at this point, liquid starts to change into solid, which means that from Q to R, what happened is that the temperature remains constant. Heat energy is released. Now from Q to R, heat energy is released because when the particles are attracted to each other, heat energy is actually given off. Now why is the temperature doesn't decrease when heat energy is given off? When heat energy is released, why isn't there a drop in temperature? Now this is because, again, there is no change in the kinetic energy of the particles. Okay, heat being released doesn't mean that the particles move slower, because when the particles are, let's say for example, you have, let's say we look at two particles. When the two particles come together and then form a bond, the heat energy is released, but the kinetic energy, the movement of the particles, will still be the same. Okay, so just remember that from Q to R, there is actually heat energy being released, but there isn't a drop in temperature. So you have to know the heat energy released, where does it come from? It comes from where the particles are attracted to each other to form solid, to form a bond. Alright, then after that, from R to S, all liquid. So at this point, all liquid would have become solid, and then after that it would continue to cool. Now the last part is on the different types of heating and cooling curve. All these four, 1, 2, 3, 1, 2, 3, 4. These four are basically heating curve. These two are cooling curve. Alright. So heating curve. Now remember, always this is the room temperature. Then after that, this would be the if let's say this is a solid, this would be from this point, this region, it would be mixture of solid and liquid, and then this would be the melting point, and then this is the liquid. So you need to know at different part of the heating curve, what states of matter does the substance exist in. Okay, again this one, if let's say this is liquid, so this would be gas, and then this would be the mixture of gas and liquid, and this would be the boiling point, because in order for liquid to change to gas, it needs to go through the boiling point. Okay, likewise for this, solid, liquid, gas. So solid and liquid, so this one would be mixture of solid and liquid. See, liquid and gas, this would be a mixture of gas and liquid. Mixture of gas and liquid. From liquid change to gas, the temperature is the boiling point. From solid change to liquid, the temperature here must be the melting point. Okay, likewise for this too. And this one is quite similar to the heating curve of the second page of the mind map, except that this heating curve is heating liquid. That means this would be the boiling point. Heating liquid, so all this will be liquid, liquid gas, then after that become gas. And the other thing is the boiling chips. So when you heat a liquid, you have to put some boiling chips, and the purpose of the boiling chips is to ensure smooth boiling. Alright, so that would conclude the kinetic particle theory. So again, this table is extremely important. You have to memorize all the keywords. It's a bit noisy outside because there is a playground there. And then the differences between the boiling and the evaporation. And then you need to know which change of matters, which change of states involve absorb of heat and which change of matters involve release of heat. You need to know that. And for this, very important, you need to know this horizontal region here. Why isn't there an increase in temperature even though heat is provided? Very important. This is for the heating curve. Same thing for the cooling curve. Why isn't there an increase or a drop in temperature? And the various types of heating and cooling curve. Remember, the horizontal line, the horizontal region must be a mixture. So you need to figure out whether it's a mixture of solid and liquid or liquid and gas. Alright, with that will conclude the video on the mind map of kinetic particle theory. Bye bye.